Hi. Okay, today we are going to learn about mechanics and particularly Newton's laws of motion. Sir Isaac Newton laid down 3 laws of linear motion in his Principia Mathematica project, and these laws would change the mankind perception in classical mechanics, and up to date Sir Isaac Newton is known as the father of classical mechanics. Okay, Newton laid down 3 laws, as I have said, and these laws were named as Newton's. The first law is Newton's first law of motion, and the second called Newton's second law of motion, and the last is Newton's third law of motion. Okay, under this topic we shall be dealing with these 3 laws together with the linear momentum and the principle of conservation of linear momentum. Linear plus linear momentum and the principle of conservation of linear momentum P. Okay, let us now start with Newton's first law of motion, which is the law of inertia. Newton's first law of motion. Okay, according to Newton, Newton's first law of motion stated that every body continues in its state of rest or state of uniform motion unless it is compelled to an external force causing to change its state. So Newton's first law of motion, as I have said, stated that every body continues in its state of rest or uniform motion in a straight line. Unless it is compared to an external force. So Newton said every body will continue to be in its state whether of rest or moving in a straight line with the constant velocity if there is no external force applied to change that state of the body. For example, the lamp on the ceiling there will proceed to be at rest if there is no external force applied to remove it. Or the computers on the table will proceed to be there unless there is an external force is applied to remove or to change the position of these computers. Or the car moving with the constant velocity will proceed with that state unless it is compelled to an external force, or unless the driver applies brakes to stop the car. Or the car, before it starts motion, will proceed to be at rest before the driver set the car to be in motion. This is Newton's first law of motion, or the law of inertia. Now, why Newton's first law of motion is known as the law of inertia? And what is inertia? Inertia of a body, this is defined as the ability of the body to resist motion or to continue moving in a straight line with the constant velocity if there is no external force applied on it. The ability of the body to resist motion or to continue moving in a straight line with constant velocity if there is no external force applied to change the state. If there is no external force applied to change the state. And the inertia of a body can be described in 3 categories. There is inertia of rest. There is inertia of motion. There is inertia of direction. Inertia of direction. However, inertia can be described in terms of translational motion or rotational motion. But here, in Newton's laws of motion, we consider the translational motion of a body. And now, what is inertia of rest? Inertia of rest, this is the ability of the body to resist motion, or the ability of the body to continue to be at rest if there is no external force applied to change the state. And inertia of motion is the ability of the body to proceed, to continue moving in a straight line with the constant velocity if there is no external force applied to change the motion. Inertia of motion, this is the ability of the body to continue moving in a straight line with the constant velocity unless it is compared to an external force to change the motion. And inertia of direction, this is the ability of the body to proceed moving in a straight line with the constant velocity without changing the direction. As we know, velocity is a vector quantity, so it has magnitude and direction. So the ability of a body to move in a straight line with the same direction, it is so-called inertia of direction. Now, why Newton's first law of motion, sometimes it is termed as the law of inertia, because of the definition of inertia of the body. So the explanation of inertia coincides with the state of Newton's first law of motion. So Newton's first law of motion, sometimes it is called the law of inertia. Okay. Newton's first law of motion, or the law of inertia, has many applications in daily life. For example, when we consider the phenomenon of the passengers inside a fast-moving car, the passengers will tend to move forward when suddenly the driver applies brake to stop the car. Now, why? This is because of the law of inertia. When the driver suddenly applies brake, the lower parts of the passengers, body are said to be at rest, while the upper part resists changes. Eventually, they tend to move forward. Also, before the car starts motion, the passengers inside the car are at rest. But when the car suddenly starts motion, the passengers inside the car will tend to move backwards. Why? Because of inertia. Because of inertia. This happens because when the car starts motion, the lower parts of passengers' bodies are said to be in motion, while the upper part resists the changes. As a result, they tend to move backwards. That is why you can say your inertia can kill you. Your inertia can kill you. Can kill you. Why? Why your inertia can kill you? Suppose you move forward suddenly, because this is an instantaneous movement, unconscious movement, and you find that you hit or you fall on the seats or any other bodies, you'll be destroyed. Another example, or another phenomena which obeys Newton's first law of motion is when we shake the branch of mango tree, mangoes fall down. Why? Because of inertia. Now, why inertia? Suppose when we shake the branch of the mango tree, we disturb the mangoes. We set the branches to be in motion, while the mangoes try to resist the changes. As a result, they detach from the branch of the mango tree and fall down. Likewise, when we hit the carpet, dust is given out. Okay? Newton's first law of motion mathematically can be expressed as the net force acting on an object is equal to 0. This means that there is no any force acting on an object, because the body proceeds to be at rest, or the body doesn't change its velocity. So the net force, the equilibrium force on the body, acting on the body, is equal to 0. This is Newton. This is Newton's first law of motion. Newton's first law of motion. Thank you. Don't forget to subscribe to my channel for more lectures, but also comment and like.